All right. So let's take a look here at a problem. All right. So let's say we have some directions here that want us to find the center and radius, okay, of a circle here. All right. And let's say the equation for our circle is something like this. So this is the equation of a circle, all right? So it's going to have a center, it's going to have a radius, but the problem that we run into here is it is not in this form that we saw yesterday where the x minus h quantity squared, y minus k quantity squared equals the radius squared, right? It's not in that format. And so because it's not in that format, right, we cannot just kind of immediately pull out the center and radius like we did yesterday. Okay? It's just not possible. All right. Yet we need to rewrite this. Just like if I gave you kind of like a random equation of a line, and if it wasn't in slope-intercept form, right? If you rewrote that equation of your line in slope-intercept form, then you would have the slope and the y-intercept, and then you would be good to go. Same idea here, right? We're not in the right form. We have to rewrite it into our kind of standard form there, I believe is the name for that. And so how do we do that, right? Well, we'll come back to this. All right. So before we run into that, we're going to need to use something called completing the square. So we'll pause and come back there to that. Okay. Completing the square, when I was in high school and learning, all this stuff that you guys are, I remember being a little challenging, right? Because it's a little funky. You're doing what seems to be like a little bit of magic to make things work out the way you want them to work out and stuff. So I'll try and explain it in a way that makes sense and stuff like that. All right, so again, we're going to come back to this. And how do we know we need to complete the square? Well, the idea, right, as you can see, we have what is a perfect square here, right? We have something squared plus another something squared. So these are both perfect squares, right? And the radius is also a perfect square. And so here, though, if we look, well, we do have x squared, but then we also have this like 6x as well right here. And same thing here, y squared, we have that minus 10y, and then the plus 18. And all those things, yeah, x and y are perfect squares, but these are not perfect squares. So what do you have to do? Well, let me start with a simpler one. Let's say we have x squared plus 6x minus 7, and that's equal to 0. Okay. All right, a trinomial or a quadratic equation here, what do you want to call it, right? And we'll spend more time on quadratic equations too later, but you've seen them before, so hopefully it's not like completely foreign to you here. But we know, right, that to solve an equation like this, we can solve this by factoring, right? We know that like an x has got to go there, and an x has got to go there, right? And we need to come up with two numbers that multiply to make the negative 7 here, right? And these same two numbers are going to have to add to make the 6 there, right? And so what two numbers are we going to put there? Negative 1 and 7, or 7 and negative 1. Exactly right. So I'm just going to put it in that order right there. Okay. Right. And again, we know that's got to be true because of our familiarity with how how we understand how these things multiply out, right? You didn't learn how to factor first. You first learned how to multiply these two things together. And once you kind of like saw what happened over and over and over again, right? The x's multiplied to give us the x squared. You had the 7x, but also the minus 1x that would add to give us the 6. And then the 7 and the negative 1 multiplied to give us the negative 7. After doing tons of these multiplications, then and only then you start going backwards and say, oh, well then if I've got something that looks like this, that means it might factor back to a product of these two binomials, right? And of course we can solve from here and say, okay, there x plus 7 equals 0, x minus 1 equals 0, dot, 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 dot. We're not interested in actually solving it here, just like that whole factoring part. Now, is this a perfect square? Okay, how do we know it's not a perfect square? What would you say?
If there is an x value.
There's an x value, okay? So I mean, well, we have some x values here we could get, right? Like x equals -7, x equals 1. But for something to be a perfect square, something's got to multiply by itself, right? And if you look here, we have two things that multiply to give us that x squared plus 6x minus 7. But they're not the same thing. They're different things, all right? And so this is not a perfect square because these two things are different. The factors are different here, okay? So what do? This is where we can, so what we do when we complete the square, we take something that is not a perfect square, right? This is a product of x plus 7 and x minus 1. So we take something that's not a perfect square and we make it a perfect square. Okay, we make it a perfect square. All right. So the way we're going to do that is kind of like what we did before, all right, where we talked about, okay, we need two things. We need to have an x and an x in there. So far, so good, right? This thing has an x at the front. This thing has an x in the front. But now we need two numbers here that are going to be the same number, okay? Now, these two numbers are still going to have to add to make what? 6, right? Now, what two numbers could we use to add to make 6 and they'll be the same number? 3. So let's put a 3 in here and a 3 in here. Okay. Now, the problem with this, though, is that if we multiply this back out together, I'll get the x squared. I'll get 3x and 3x. That makes 6x. But then 3 times 3 is going to be what? 9. And what do we have? -7, right? Okay, that's a problem. But if we kind of leave that -7 further over here, right? And if I just bring in +9, like just add it in to the left-hand side of my equation. I know I'm kind of like adding a step above there, but let's just say I do that, okay? If I add a 9 in, well now this will become that x plus 3 times x plus 3, right? But I can't just add 9 in from nowhere, right? If I add 9 to the left-hand side, what do I have to do to balance out my equation? Add to the right-hand side, right? So I'm going to add a 9 over here as well. Okay? And so then instead of having a 0 here now, we'll say that that is equal, and I guess I can, well, let's see here. Now this is going to get a little funky here. So let me do, let me do it this way. I'll put the -7 right there, equals then the 9. So we're kind of like jumping down back to this step now. Okay? So we have that, this is x plus 3 times x plus 3 minus 7, and then equals the 9 there. Okay, and so we get x plus 3 squared minus 7 equals 9, or we can add the 7 over and make it x plus 3 squared equals 15, 16. Can't add. Okay. And now we've created a perfect square, right? Something that was not a perfect square, we made now a perfect square by making a slight adjustment to the left and right-hand side of our equation, kind of balance it out, right? And to make it a perfect square. Okay? Now, that's kind of like the idea behind this, all right? But what really happens in practice here? Well, we take something, x squared plus 6x, okay, minus 7 there, and we look at that middle term, right? And maybe your teacher taught you this way, where it's just like, if you take half the middle term, okay, right, that'll give you what this is going to factor to be, so the x plus 3, x plus 3. And then square it, you're going to add 9 to both sides to kind of make it a perfect square. Okay, so let me show you another example of this here real quick, what I mean by that. Let me do another, complete the square. Okay, so let me just show you what I mean by that. So let's say we've got m squared plus 10m plus 14 equals -7. Okay. One recommendation that I like to make too is to kind of like move the 14, move any of your numbers over to the other side here. So we'll make it m squared plus 10m, leave some space, because we know we're going to have to balance out to make a perfect square here, and we'll subtract the 14 over, make it -21, like that. Okay. So move any of your constants, like the 14 there, over. Just leave it m squared plus 10n equals negative 21. Again, we know we want this thing to factor, but we want it to be a perfect square. So we're going to have m and an m to make the m squared. M and m to make the m squared there. But again, we need two numbers here that add up to make 10, and we want these two numbers to be the same. So what two numbers are they going to have to be? 5 and 5, right? So plus 5, plus 5. But then in order for this to multiply back together correctly, I'm going to have the m squared. I'll have 5m plus another 5m to make the 10m. But then what do I need in here? To complete it, I need a plus 25. So I'm going to add in a plus 25. And do it to the same, do it to the other side too, of course. Right? Add another 25 to make that a perfect square. And so negative 21 plus 25 is 4. Okay? And then we get m plus 5 quantity squared equals 4. Okay. And of course, we could solve this, right? So this is a method to solve a quadratic equation. I'm going to guess most of you probably don't use this as a strategy to solve quadratic equations, but you can. All right. If we then just square root both sides here, we get m plus 5 equals plus or minus 2. And so we get m plus 5 equals 2, m plus 5 equals negative 2. And so m is negative 3, or m is negative 7. Okay, right? If we want to solve it. The directions did say solve, so. Okay. All right, let me do one more here, and then I'll give you guys one to try on your own. Okay. So for this one, we'll just complete the square. Okay. Okay, we'll just complete the square. We won't worry about solving, just to save ourselves some time here. All right, so x squared plus 12x plus 20, we'll say, equals 0. Again, this thing factors. This thing factors, right? You could factor it to be x plus 2 times x plus 10. It factors, but it doesn't factor immediately to a perfect square. So we need to complete the square. We need to make it a perfect square. So again, subtract that 20 over and leave some space in here because we know sometimes we have to add in that kind of correction. Okay. And we're going to need an x here and an x here. And we have two numbers here that add up to 12, but we want them to be the same, so they have to be what? 6. All right, so plus 6, which means then what value is missing here? 36. We got to add in a 36, because then 6 times 6 would be 36, so we need to put in a 36 there to make it factor right, and we'll add 36 over to this side as well. Okay, and so then negative 20 plus 36 is going to give us 16, and so we get x plus 6 squared equals 16, and again, I'm not going to have a solve for that, but we could. All right, so there it is, a perfect square now. Made something that was not a perfect square, we made it a perfect square now. Okay, questions on any of that? Ready to try one on your own now? I'll take your silence as a yes. So here we go. All right. All right, so try this one. And again, I'll just have you complete the square. We won't worry about actually solving. P squared minus 18p, not 18, p squared minus 8p plus 15 equals 0. So try that one. Just complete the square. Don't worry about solving the equation. If you want to solve the equation, feel free to. But just go ahead and complete the square there. Okay. Volunteers here want to share what they got when they completed the square? Anyone want to volunteer? Yep. Go ahead, Hayden.
P minus 4 quantity squared equals 1.
Perfect. There you go. Okay. And if you solved it, should have gotten, whoops, 5 and 3 are your two solutions there. Again, you square root both sides. So you have plus or minus 1 equals p minus 4, and then break the two equations there into p minus 4 equals positive 1, p minus 4 equals negative 1, and then solve, and you get your answer. All right. So we're feeling pretty good about completing the square? Yeah. All right. So let's go back to where we were then about talking with, or about looking at our circle, and then how we can make that circle match what we were looking for there. So dot, dot, dot. Okay, again, we were finding the center and radius. And our circle was x squared and plus y squared plus 6x minus 10y plus 18 equals 0. All right? Now, this is a little bit trickier because we have both x's and y's, and so we want to be a little more careful. The same recommendation we used before, though, where we had that plus 18, let's move that over to the other side. Simultaneously, I'm also going to rearrange my terms here so that I have my x squareds and x's together and my y squared and y's together, all right? So we'll make this x squared plus 6x, leave some space for that completion of the square, right? Plus y squared minus 10y, leave some space for that completion of the square, right? And then equals negative 18, because I, of course, want to subtract the 18 over there to the other side. All right. So let's look at the x terms here, right? We need an x there, we'll need an x here, plus, and then we'll need a y there and a y here. Okay? So, for the x's, right? What number are we going to put in there with the x's? 3, that's right. Okay, again, we need two numbers we're going to add to 6 and let them be the same, so it'll be 3 and 3. Okay? Which means, back up here in our previous step, what number do we need to put in? A 9, right? Plus 9. And then to balance it out, we'll put the plus 9 on the other side of the equation. Okay? Don't forget to put this plus 9 on the other side of the equation here, right? It's easy to get so caught up in this process over here, you forget you got to balance it out. So don't forget that plus 9. All right? It's an easy mistake that I see, or a common mistake that I see. All right, over here with the y's, what should we put with that? We need negative 5, right? Again, we need two numbers that add to negative 10. We need to do the same number, so minus 5 there. And then what's going to be the number we have to add in here to complete that square? 25. So plus 25, and again, balance it out on the other side there. All right. So negative 18 plus 9 plus 25, 15? 16? Yeah, math, right? Who knows that? All right, 16. Perfect. So now we can finish putting these together. We have x plus 3 quantity squared plus y minus 5 quantity squared equals 16. All right. And there's the equation of our circle, right? The center of the circle is negative 3, 5. Right? Remember, it's the opposite of the sign. It should be x minus h. So if you have a plus 3, that means it's going to be negative 3. And y minus k, so it'll be 5 there. Okay, that's the center. And then the radius will be? Good, I didn't hear any 16s. Okay. Maybe someone was thinking it, though. Well, I can't hear your thoughts. All right, so there it is. All right. Questions on any of that? We'll do one more here together, and then I think I'll give you guys one to try. Actually, two to try after this. So we'll do one together, one more together, and then I'll give you guys two to try on your own. All right. 3x squared plus 3y squared minus 6y plus 15x plus 9 equals 0. Okay, so Here I've thrown in some coefficients in front of our x squared and y squared terms, right? Do we have coefficients in front of our x or our y here in our standard circle equation? No. So that means we need to get rid of these. How should we go about getting rid of the 3's there in front of the x squared and y squared? We're going to factor out a greatest common factor or just divide both sides by 3. Either way you want to do it there is fine. So it's really up to you. Let's just divide both sides by 3. How about that? So if we divide both sides by 3, okay, so I'm just divide the entire side here by 3, divide this entire side by 3. Okay. 3x squared divided by 3, x squared. 3y squared divided by 3, y squared. Minus 6y divided by 3, negative 2y. 15x divided by 3, plus 5x. 9 divided by 3 is 3. And that equals 0. Doesn't that look, bless you, doesn't it look much more nice now, right? Okay. So again, we will collect our x terms and y terms together. So it'll be x squared plus 5x, leave some space, y squared minus 2y, leave some space, equals, and then we'll move that 3 over. So equals negative 3. Okay. For circles, by the way, let me just put this up here. For circles, the coefficient, okay, of the square terms must be 1. Okay, whoops, I'm off the screen. There we go. Okay, for circles, the coefficient of the square terms must be 1. That's why we had to divide both sides by 3 there. Okay. Other shapes get created if you start like adding in coefficients and when you can't divide them out, kind of thing. So if like this was a 3 and that was a 2, that would change the shape. Okay, actually I think it would result in an ellipse, I believe. Okay, not a circle. Okay. So anyway, we collected our terms together here. So we've got x and x, and y and y. All right. So let's go ahead and complete this square here. So we need two numbers that add to make 5, and they need to be the same number. So, whoa, 2.5. Mr. Wid, fractions? Yes, fractions. I'm going to say 5 halves instead of 2.5 there. Okay. Neat. Question?
Does it have to always be in fractions, or can you also do decimals?
You can use decimals if you want to, but my recommendation, I think, is that you get comfortable with these improper fractions because it makes the arithmetic easier. In my opinion, I find it easier to multiply 5 halves times 5 halves than 2.5 times 2.5. That's me, but I really do feel like in general it's a good strategy, But you can do whatever you want. I'm not gonna, you do whatever you want. Okay. So now that being said, right, we've got our 5 halves here and our 5 halves here. What number is going to go right here? Oh, Ramika, you have a question?
No, I was
Are you going to say? Yeah. What is?
25 over 4.
Yes. 25 over 4. Exactly right. Okay, so plus 25 fourths there. That is 5 halves times 5 halves, right? 25 fourths, which we'll have to add 25 fourths over to this side. All right, how about this one right here? We have to add to negative 2. What two numbers that are going to be the same? We'll add to negative 2. Negative 1, negative 1. You got it. Okay. And then what negative 1 times negative 1 is going to give us a plus. Oops, let me do that in red. I meant to do that in red. A plus 1 there, and so we'll add 1 over to that side too. Okay. Just like that to balance it out. Okay, got to add these numbers together over here, and one of them is a fraction. So let's see here. Negative 3 is the same thing as negative 12 fourths plus 25 fourths, and then 1 is 4 fourths. Okay. And so we get then x plus 5 halves squared plus y minus 1 squared equals 17 fourths. Okay. Good. And so then the center in our case is going to be negative 5 halves, comma 1. And the radius will be the square root of 17 fourths. Remember, when you take the square root of a fraction or the square root of a division problem there, you can break that square root up over the numerator and the denominator. And so we get really root 17 over 2. Okay, for our final radius. And then there's this center. Questions on any of that? Yes?
Is it okay if I don't have it in fraction and then just do it with 1 under the decimal?
Yep, that's fine. That's fine. Okay, as long as it's equivalent, you know. If you know, of course, if you have like a repeating decimal, make sure you put like a bar above it or something like that. That's fine. But yeah, that should be fine there, Jackson. All right. Any other questions before I get you guys started? So I'm going to give you 2 here to try on your own, and then we'll get you started on the assignment for today. Okay, so we're just about done here. Just about done. All right. So you guys try. Same thing, just identify the center and radius. Notice the directions, right? Don't specify, don't tell you to complete the square, right? They're just saying identify the center and the radius. Okay? It's up to you to realize when you see a circle in this format, oh, I need to complete the square here. You know, that kind of thing. So, x squared plus y squared plus 4x minus 14y plus 4x minus 19 equals 0. Make sure I did that right. X squared, y squared, 4x minus 14y, 4x minus 19 equals 0. Yep. Okay, so there's that one. Find the center and radius, please. And then that's the first one. And then number 2. Yes?
They're supposed to be, you wrote down 4x twice.
Yes, I did. That is on purpose. Yep. I know, though. I do make lots of mistakes, and so, but I did actually purposely write that one down. All right, and then I have another one here. And it's going to be, well, kind of similar to it, so maybe it's not going to be as interesting, but, well, I'll let you guys figure that out for yourself. Okay. 1 and 2 are almost identical, except one has minus 19 and one has plus 100 there. You can use that to your advantage if you'd like to when you're going to do the second one, at least, you know. Or feel free to use it to your advantage when you do the second one. So go ahead. 1 and 2, identify the center and radius. I'll come around and help if you've got questions or anything like that. Oh, great. Thank you, Silas. All right. Does anyone still need more time? Mr. Wood, you gave us too much time. Right. All right. So here we go. Oops. So the first one here, right? I guess we'll just run through this one here. So rearrange our terms, right? X squared plus 4x, leave some space. Y squared. Ooh. We have two 4x's, right? So this should really be 8x. We want to combine those like terms together there. Now the y squared is only the minus 14y this time, so we'll leave it like that. Leave some space. I'm going to move that 19 over so it equals 19. So when we go to complete the square here, it's going to be x. What number goes in here? 4 plus 4 and plus 4 there. And so we'll add in 16, right, to keep that, to now make that factor correctly there. So we complete the square with that. And then here we're going to put in a minus 7, right? And so that's plus 49. Squeeze that in there. I'm going to add 49 over here as well. Okay? And so we end up with 84 there. And so we get x plus 4 squared plus y minus 7 squared equals 84. So the center, negative 4, 7. Radius, square root of 84. Did anyone simplify it? Hallie? 2. Okay, I see what you're saying. Yeah. So in other words, just 21. We'll just leave that as 21. Yep. Mm-hmm. That's fine. Okay, 2 square roots of 21. Yep. Okay, so there's our radius and there's our center. Questions on that one? All right, so the same exact thing happens here, except we're going to have a plus 100, and that 100 moves over. So I'm just going to like dot, dot, dot. We're going to have negative 100 here, and we have to add, again, the 16 and the 49 to that to make this work out right. But then when we add the negative 100 plus the 16 plus the 49, what do we get? Negative 35. Okay. So the center of the circle, okay, negative 4, 7 again. The radius of the circle is, off the screen. Radius of the circle is, yes. Okay, right. So we end up with something imaginary, right? Let me do it more simply here. We'll just leave it as square root of negative 35. Okay, right, which, we could simplify to I root 35. Okay? Or in other words, the circle does not exist because the radius is what? Imaginary. Okay? When it comes to circles, we got to keep it real. All right? No imaginary radii. Circle cannot exist, does not exist, cannot exist because the radius is imaginary. Okay? The circle is not imaginary, the radius is imaginary, right? And therefore the circle does not exist. Okay? A little bit of a distinction there. All right, questions on any of that? So that wasn't a mistake. I actually meant to give it to you that way. So, all good? All right, so your assignment then, well, you've got choices. You've got choices. So let me show you what I mean by your choices here. Okay, let me show you what I mean by your choices. On the Google Classroom, stop the video.